Welcome to this introduction video about our new power distribution board, Dianomē. Dianomē is a compact board that serves to power and protect your electronics. It has an XT60 power connector for the input and 6 XT30 power connectors for distribution. It also features a header for a switch. Most importantly, however, Dianomē protects your electronics from the adverse effects of inrush current. Inrush current is a surge of current that occurs when the device is first turned on. The capacitance of the load combined with the parasitic self-inductance of the conductors creates a condition where current draw is orders of magnitude larger than nominal, while voltage across the device terminals also overshoots. In this idealized simulation, we note an inrush current of 1 kA and a voltage overshoot of 20 volts. These values are certainly enough to damage the load electronics. Dianomē protects by gradually turning on the MOSFET that acts as a switch. In other words, driving the MOSFET through its ohmic region. This is the rough equivalent of having a potentiometer and gradually turning it on. Let us take a closer look at how Dianomē protects from inrush current through testing. In this test setup, we have the following components: an upstream capacitor bank with a capacitance of 6000 microfarads, a downstream capacitor bank with a capacitance of 2000 microfarads, and a current sensor between the two. This setup emulates connecting a capacitive load to a power source. With the downstream plug disconnected, the upstream bank is charged. Then the plug is connected. Here we see the scope plot that was captured at the time of switching on. The blue line represents the bus voltage, while the yellow line is the voltage presented by the current sensor, proportional to the measured current. Peak current is observed 110 microseconds after switching on. A 3.5 volts reading corresponds to roughly 50 amps. We will now introduce the Dianomē between the current sensor and the downstream capacitor bank. The Dianomē will limit inrush current, and this will be visible in the current sensor measurements. Let's connect the plug. Let us take a look at the scope plot once again. Again, the blue line is the voltage across the DC bus, and the yellow line is the voltage reported by the current sensor. We note a linear rise in the DC link voltage. This lasts for approximately 50 milliseconds. We also note that the current during switch on is negligible. This validates the protection function of the power distribution board. Thanks for watching this video. For more information, check out our website tinymover.com.